Okay, ladies, in this video, we're going to look at parallel and perpendicular lines. So we're going to finish chapter 4 here and come back to the rest of the topic at another point. Okay, so perpendicular and parallel lines, you probably understand what a parallel line is and what a perpendicular line is, but you need to know how they relate, lines relate with their gradients. Now, first one is easy. If two lines are parallel, then they have the same gradient. So you can see on this diagram here, just on the right-hand side, the blue line and the green line both have the same gradient of 2. They go through a different y-intercept, but you can see that they're parallel and they've also got the same gradient. Now, if two lines are perpendicular, and perpendicular just means they meet at right angles, we call their gradients M1 and M2. So you know the letter M we use for gradient. So M1 just being the gradient of one line and M2 being the gradient of the other line. So basically, if we're finding out, if we're given one gradient and we need to know the gradient of the other, so we've got this formula here. So when we multiply the two gradients, we get -1. But basically, this is the formula that we're going to be using. So the gradient of one line is, well, when they're perpendicular, is given by the negative reciprocal. So what it means by reciprocal is we just flip it. Okay, so let's just go over here. So if I had 3/4, the reciprocal is 4/3. Okay, but this time we're taking the negative reciprocal. So if that was positive, the negative reciprocal would be that. Now, if we had, let's say, -2, we're taking the negative reciprocal of that. It means it's going to be positive, okay, because it's the opposite sign. And when we flip 2, it becomes a half. Okay, so when you think of the number 2 as just 2/1, when we flip it, it becomes 1/2. Okay, so that's what you need to know. Flip it and multiply it by a negative. So if it's already a negative, it becomes a positive. If it's already a positive, it becomes a negative, and you just flip it. Okay, so let's have a look at question number 4. Okay, so leading up to this, it was pretty straightforward, but here we're writing the actual equation. So question, and I'm going to do 4 and C because B is another parallel one. I've got 2 parallels, so I'm going to do A and C. Write the equation of the line parallel to y = 4, which passes through these points. So if it helps, you can quickly draw the graph. So y = 4 is here. Okay, so it's a horizontal line going through y = 4, and the gradient is 0. So that means for all the other lines, they're just going to be y equals whatever the y coordinate is. So for this one, it's 1. So it's going to be y = 1. So if you think about it, your line is going to go through there at 1. And for the second one, we're going to have y = -2. So it doesn't matter what the x coordinate is, because in this case, because they're just horizontal lines. Sorry, I should really stop making these videos because for today, because I'm getting very tired. Okay, and there's your second one. Okay, so if you want, let's do B. Oh, actually, yeah, let's do B. Just because I want to. That was quick. Was quicker than I thought. Okay, so for this one, we've got x = -2. So there's x = -2 there. So we're working with vertical lines. So we're only looking at now the x coordinate. So the first one is going to be x = whatever the x coordinate is, which is 3. Okay, so if we drew the line, x = 3, there it is, not to scale. And then the second one is going to be x = -3. So you're going to have a line down here at -3. But see how they're parallel. Okay, and those lines are parallel. Okay, so question C. Write the equation of the line perpendicular to y equals -3. So I might just scroll down and give me some space. Okay, so we're doing perpendicular to y equals -3. So there's y equals -3. And oops, got to see what the actual question is. 2, 0. So it's passing through to 0. Now, these are, because this is a horizontal line, the perpendicular line is going to be a vertical line, and it's going to be passing through whatever that x coordinate is. So there it is, there at x equals 2. And then this one here is just your y-axis. So it's going to be x equals 0. So those lines they're not always going to be that easy. So let's move on to question 5, which is a little bit harder. Find the equation of the line which is parallel to the line with the equation -3x minus 7 and passes through 3, 0. So let's first of all identify what our gradient is. So if the lines are parallel, the gradient's going to be the same, and the gradient of this line is -3. Now it passes through 3, 0. So that point is also your x-intercept. Yes, x-intercept is at 3. Now that's not really important here, but if it was 0, 3, then we've got straight away our y-intercept, but here we've got our x-intercept. So we're finding the equation, we're going to just substitute it into y equals mx plus c. Okay, so this is your x and your y. So we've got 0 equals -3 times 3 plus c. And then we're just solving for c. So -3 times 3 is 9. So c is equal to -9. So your equation is going to be y equals -3x minus 9. All right, let's just go to question B. So I might have to just keep scrolling up. Actually, I've got the textbook right in front of me, but I don't have it open to the right page. So we're looking at parallel half x plus 2. And passing through 1, 3. Okay, so let's identify our gradient first of all, which is the coefficient of x, which is a half, and then we're going to substitute it into y equals mx plus c. So we've got y equals 3, m is a half, x is 1. So we've got half times 1 is a half, and that gives us c equals 2.5. So your equation is y equals a half x plus 2.5. And you can put them as fractions if you wanted to. All right, question C. So we've got a perpendicular one now. 5, -4. And passing through, was it 1, 6? Let me just double check. Okay. All right, so same as before, identifying the gradient first. So the gradient of this one, so we'll call that m1, is 5. So your other gradient is just the negative reciprocal. So this number is positive, so I'm going to make this one negative. And this number is 5 over 1, so if I flipped it, it's going to be 1 over 5. Okay, so there's our gradient. And we're just going to substitute it now into y equals mx plus c. So y is 6. Your gradient is -1 on 5 times x, which is 1, plus c. So 6 equals -5 times 1. It's just -1 on 5, sorry, c. So c is equal to 6 and 1/5. So your equation is going to be y equals -1/5 x plus 6 and 1/5. All right, now I've run out of space there, but you're working out, let me just talk you through question D before I move on. And I might just put a line here. So your gradient for D, the first one, is -1. So your second gradient, the gradient of the line that's perpendicular, is the negative reciprocal. So because that one's already negative, it's going to be positive. And this is -1 on 1. So your other gradient is just going to be +1. Okay, and then you substitute that into y equals mx plus c. All right, question 6. So a right-angled isosceles triangle has vertices at 0, 3, which is here, 3, 0, here, and -3, 0, which is here. Find the equation of each side. So the easy one to do is this horizontal line, because that is just y equals 0. Okay, so y equals 0 is here. And we can say that is for between x is going from -3 to 3. Okay, so it doesn't keep going, it stops at -3 and 3. All right, so this line here, so that's 1. Let's do this one here. Okay, so your gradient of that line, remember, is just rise over run. So we've gone from 0 up to 3, so it's 3. And we've gone across from -3 to 0. So your gradient of that line is 1. So we're just going to substitute that into y equals mx plus c. So you can put in either point. I'm going to put in 0, 3 just because I don't like negative numbers. Okay, so we've got 3 equals, oh, actually, what am I doing? I don't need to do that because we can clearly see what the y-intercept is. Anyway, let's just do it anyway. Let's just pretend I didn't realize that. But so your y-intercept is 3, which we could easily see from the graph. Okay, so our equation is y equals 1x. We can just write x plus 3. And that is from -3 to 0. So we're going from -3 to 0. Okay, so it's only true from there. And then the third one, now we can work out that gradient, but it's a perpendicular line. It's perpendicular to this one, and that's indicated by that right angle. So we've got y equals, if this gradient was 1, this one's going to be -1. And you can see that your y-intercept is there at 3, so I don't need to really work that out. So we've got y equals -x plus 3, and that is from x is between 0 and 3. All right, I think that's the last question I was doing for this one. Might just scroll to make sure. Good. All right, bye.